Welcome back. So today we are going to solve Leetcode 153, find minimum in rotated sorted array. We are given with an array of length n sorted in ascending order and is rotated between 1 to n times. For example, the array nums is equal to 0, 1, 2, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2 if it was rotated 4 times, and it would be just in its original form if it was rotated 7 times, or you can say if it was rotated 0 times. Notice that rotating an array a0 a1 a2 till an minus 1 one time results in the array a9 an minus 1. So basically it's saying if it was rotated one time, so the n minus 1 element would have moved front. Given the sorted array of nums of unique elements, remember the elements in nums array are all unique, we have to return the minimum element in this array, and we have to do that thing of finding the minimum in logarithmic time, which is O log of n time. N means the length of the array. So yeah, given here an example. So, and also the array is rotated 3 times. So what's the minimum elements? You can say it's 1. So our answer will be 1. Now, how we would be approaching this question? You can carefully observe the minimum element is the one which is smaller than the element to its left. So basically, if this condition is met in our iteration when we were going through the array, and if we meet a condition where the current element is smaller than the element to its left, then we can directly return that current element as the smallest. Else, another thing to be noted here is, suppose we were here, our mid point was here, let's say low and let's say it high, then you can see the minimum element is always lying in the unsorted part. So this is the unsorted part and this is the sorted part. So if we can check if the mid element is greater than the uh, element at low pointer and is also greater than the element at the high pointer, sorry, yeah, then we can safely assume that our smallest element would definitely lie in the higher search range. Else, if the condition is not met, we would continue to search in the lower search range. So that thing, I think that should work, and we should try this approach to code. So yeah, let's code this up. So we are in our code editor. So let's mark the low and high pointers at 0 and len of nums minus 1. By the way, let's also make a answer variable and store answer initially to be 0. This is a safe approach, since there might be there a condition where the array wasn't rotated and was in its original form, sorted, fully sorted, not rotated. So basically the answer would have been the first element of the array. So this would be the safe thing to do start with. So now let's iterate until the low pointer is less than equal to the high pointer, get the mid pointer, which is low plus high by 2, sorry, high by 2. Also, let's keep track of the current element, which is the element at the mid index. Now, let's see if the current element was smaller. I mean, if the element to the left of the current element was greater, then we can directly return current element as our answer. Also, one thing to keep in mind is to check in bounds. So we should also check if the mid index is greater than 0. Now, coming to the another checks, if we have already discussed, if the current element was greater than or equal to the element at the high pointer, and if it was also greater than the element at the low pointer, then it would be safe to discard the lower half and search. It would be better to search in the unsorted part, which currently lies. You can see this is the unsorted part. So basically, it's in the higher. So we would be moving the low to the higher search range, which is low to mid plus one. Else, we can continue searching in the lower search range, which is high school to mid minus one. Now, finally, we can return the answer. So let's check. And as you can see, it was accepted. So let's also check if it passes all the test cases. And yeah, it passed all the test cases and it is pretty efficient as well. So this was it, and I hope to see you soon in the next video.